Hi everyone, I hope you're okay. This is question 10, guys, and I'm doing video number 10 as well. The last video of the question paper. Is it the last video? Oh, there's still question 11. Okay, it's the second last video. Which simply means that, guys, should I combine the two videos? But it's just 13 marks and 15. I'll just do this in one video, guys. Okay, in the diagram below, AT is a tangent to the circle at T. Chords BT, BV, and VC are drawn. CP is extended to A such that AC is parallel to TV and BC is equal to CV. Angle BVT is equal to X. Determine, giving reasons, 3 angles which are equal to X. They want us to find 3 angles which are equal to X. Okay, we were told about the tangent, ne? The first statement. Once they tell us about the tangent, there are 2 theorems basically that you must look for. You must look for tan-chord theorem, and you must also look for the relationship between the tangent and the diameter. Are you together? So I know that T2 will be equal to this angle over here, tan-chord theorem. So T2 will be X. These 2 lines are parallel. These lines are parallel. That means I have alternating angles. That means B1 is also X. If B1 is X, that means I also have X there. That means I also have X there. So I do have the 3 angles which are equal to X, but I just need to write them properly for me to get marks. Are you together? How am I supposed to write? Angle T2 is equal to angle V2, which is equal to X. Why? Tan chord theorem. Are we together? And then since it is given that VT is parallel to BC, I can therefore conclude that angle B1 is equal to V2, which is equal to X. These are alternating angles, and the angles are alternating. Why? Because VT is parallel to BC. Are you together? Thirdly, it was given to me that BC is equal to CV. This was given to me. So I can therefore conclude that angle V1 is equal to angle B1. That means angle V1 is also equal to X. Why? Because we have equal sides, which results into equal angles. Equal sides that result into equal angles. So the angles which are equal to X, let me write them over there. T2 is equal to X. B1 is equal to X, and V1 is also equal to X. That's how, guys, you answer, ne? You must give reasons for you to get full marks. Okay, if ATVC is a parallelogram, let me erase over here. Okay, if ATVC is a parallelogram, prove that AT is equal to BT. Where's AT? AT is equal to BT. Okay. Excuse me. If I can show that angle A is equal to this one, I can therefore conclude that AT and BT are equal. So for me to prove that AT and BT are equal, I must first prove that B3 and angle A are equal. Okay. How can I do that? How can I do that? Remember that I have X here and X there. Are you together? So therefore, angle C will just be 180 minus 2x. Why? I got it by saying the sum of angles of triangle BCV. Are you together? So since this thing is a parallelogram, I have 180 minus 2x. Né? Since this is a parallelogram, né, it simply means that AT is parallel to CV. Are you together? Remember that the opposite sides of a parallelogram are always parallel and equal. Are you together? So since that's a parallelogram, I can therefore say angle A plus angle C, they are both supplementary. Why? Because they are co-interior angles. And these two angles are co-interior because AT is parallel to CV. Why are they parallel? Because these are opposite sides of a parallelogram. Are you together? I want to find angle A. Remember that angle C is just a 180 minus 2x. Let me use a different color. Angle C is 180 minus 2x, right? And obviously this is equal to 180. Whenever I take the 180 and the 2x to the other side, I'll be left with angle A being equal to 2x. Are you together? So I now know that this angle over here, that angle there, is 2x. Okay, that angle over there is 2x. Né? Remember another thing. There's another thing that's we did. Né? We said that we've proven that angle V1 is equal to x. That means this entire angle is 2x, right? Remember that an exterior angle of a cyclic quad is equal to the interior opposite angle. So angle B3, this angle over here, is equal to this one. That's the exterior angle of a cyclic quad. So angle B3 is equal to angle V as a whole. I know that angle V is equal to 2x. That's exterior angle of cyclic quad BTVC. So now I can conclude that angle A and angle B are equal because both of them are equal to 2x. And now therefore I can say that since I've proven that this is equal to 2x, what did I write there? I just wrote B. That's B3. Remember that the exterior angle is equal to the interior opposite, right? So since I've proven that both of these angles are equal to 2x, I can therefore conclude that I have an isosceles triangle. I can therefore conclude that AT is equal to BT. AT is equal to BT. Why? because them equal angles will result in having equal sides of a triangle. So that's how, guys, you prove that you have an isosceles triangle. Just ace of 5 marks. Hambalal. Okay, and then now we must determine the size of x. Now we must determine the size of x. Let me erase here for me to write. Excuse me. How can we determine the size of x? Remember that we calculated T2 initially in the first question 10.1 rather, that T2 is equal to x because of tan chord theorem. Ne? So now I can say that T2 plus B3 plus A, angle T2 plus angle B3 plus angle A are all equal to 180 degrees because you have the sum of angles. Okay, let me not write Greek letters here, man. Sum of angles of triangle ABT. Angle T2 is equal to x, angle B3 2x, angle A is 2x. This is equal to 180 degrees. 5x is equal to 180 degrees. Therefore x is equal to 36 degrees. So that's how, guys, that's how we could have tackled question 10. Ne? Let's just get into question 11. Question 11. Okay, DE is a tangent to the larger circle at E. DE, okay, is a tangent to the larger circle at E. Immediately when they tell you about tangents, guys, you must just think of tan chord theorem. Ne? DH is a tangent to the smaller circle at H. Tangent to the smaller circle at H. Tan chord theorem, guys. Ne? Tan chord theorem. Tan chord theorem. Okay. Chord HK is extended to meet the larger circle at E. Okay. F and K are points of intersection between the circles, with FK produced to D, and then GK is a chord to the smaller circle, with EF a chord to the larger circle. HF, GH, and GH are joined. Complete the following statement. D3 is equal to the sum of two angles, ne? And because it's an exterior angle of a triangle. Where is D3? Oh, now D3. There's D3, ne? Okay, D3 is equal to the exterior angle of D3 is an exterior angle of a triangle, right? Which triangle are we looking at? D3 and let me highlight using the highlighter over here. We are focusing on this triangle over here, ne? So this angle D3, this angle over here, that angle over there is equal to this one plus this one. Are you together? The exterior angle of a triangle is always equal to the interior opposite angle. So D3 is equal to H1 plus E1. Ne? H1 plus E1. Okay, and then now let me erase this. Okay, let me leave them. Prove that DEFH is a cyclic quad. Where is D? DEFH is a cyclic quad. Oh, we are focusing on this shape, ne? Remember that if you are supposed to show that something is a cyclic quad, you either have to show that the opposite angles of that particular shape are supplementary, or show that the exterior angle is equal to the interior opposite angle, or you can show that angles in the same segment are equal. I found that this angle over here, D3, is equal to H1 plus E1. Are you together? And I know that H1 is equal to this one according to tan chord, and then E1 is equal to this one according to tan chord. So this is equal to that. So we can therefore conclude that it's a cyclic quad. Ne? But how do you write it? Being able to see it, guys, will never give you the marks, ne? But being able to write your answers will give you marks. Okay, angle E1 is equal to angle F1. Are we together? This is tan chord theorem. Are we together? And I know that angle H1 is also equal to angle F2. Same reason, tan chord theorem. Are we together? So I can simply say that angle HFE is just equal to E1 plus H1, because I've just proven that. Ne? But what do I know? I also know that angle D3 is equal to angle E1 plus H1. I've proven this in the first question. Proven in 11.1. So therefore, I know that angle D3 is equal to angle HFE. This angle over here is equal to this one. So now I can therefore conclude that DEFH is a cyclic quad. Why? The exterior angle is equal to the interior opposite angle. I was good. So therefore DEFH is a cyclic quad. I'm lazy to write cyclic quad in full. Ne? The reason, you can simply say the exterior angle is equal to the interior opposite angle. Are we together? And then now we are supposed to show that DF bisects HFE. Where is DF? Okay, DF bisects HFE. Okay, basically they want us to show that F1 and F2 are the same. Okay, how can we do that? Let me check. I've proven that these two are the same, ne? Okay, what else do you know? Remember that I can see it now. Remember that this is a cyclic quad, ne? In a cyclic quad, there are three possible things you need to look out for. Firstly, the exterior angle is equal to the exterior is equal to the interior opposite angle, né? And then opposite angles are supplementary, and then angles in the same segment must be equal. If we check chord DE subtends angle H1 and also subtends angle F1 at the circumference. Are you together? So I can therefore conclude that since I've proven that DEFH is a cyclic chord, I can conclude that these two are the same because they are angles in the same segment. Are you together? So I can conclude that angle F1 is equal to angle H1. These are angles in the same segment. Are you together? But what else do I know? Initially, I've said that angle F2 and angle H1, they are both equal because of tan chord theorem. Are you together? So this simply means that both F1 and F2 are the same because both of the angles are equal to H1, to angle H1. So if these two angles are the same, therefore DF bisects HFE. If these two angles are the same, that means this line over here bisects the angle HFE. Okay, now let's move to 11.4. Let me erase here to create some room to write. 11.4. Okay, if K1 is equal to E1, where is K1 here? K1, oh, no, K1. Okay, if K1 is equal to E1, okay, prove that GK is a tangent to the larger circle at K. GK is the tangent to the larger circle at K. Basically, we are required to show that K2 is equal to E2. That's what we are required to show. Okay, how can we do that? I can see it. Angle K2 is equal to angle H3, né? These are angles in the same segment. If you focus on the smaller circle, né, you will see that you have a situation whereby we have chord GF subtending both K2 and H3 at the circumference. So that's why K2 is equal to H3. These are angles in the same segment. These are angles in the same segment, you know? And then I know that H4 is equal to K1. H4 is equal to K1. Why? Tan chord theorem. Are we together? So therefore I can conclude that now I can conclude that remember that initially I've shown that this guy over here, I've just shown that this over here is a cyclic chord. Are you together? So if ever we have a cyclic quad, we can say that the exterior angle is equal to the interior opposite angle. Are we together? So how can you write it? You can simply say that angle H3, the sum of H3 and H4 are both equal to E1 and E2. Are you together? The reason behind exterior angle of cyclic quad DEFH. Are we together? But we do know that angle H3 is equal to what? H3 is equal to K2. H3 is just equal to K2 plus H4 is equal to K1. Are you together? Both of these are equal to E1 plus E2. Né? And then we were told there that if K1 and E1 are both equal, if these two are equal, therefore K2 will be equal to E2. So now I've proven that this guy is equal to that one. So I can therefore conclude that GK is a tangent. Why? Because I have a tangent. A tan chord theorem rather. So therefore GK is a tangent. Are you together? Why? Because there's a tan chord theorem. Tan chord theorem, I have K2 being equal to E2. That's how, guys, we would have tackled both these questions. Né? It's question 10 and 11. I really hope that, guys, the videos helped you and you are gaining a lot. Thank you for your time.